All right, so we have two masses over a frictionless pulley. We're given that M1 is 2.1 kilograms, M2 is 2.0 kilograms. So M1 is slightly bigger than M2. So we want to use 9.8 here since we're dealing with like such a small difference in masses. So if M1 is slightly bigger than M2, which way is M1 going to be moving? Down. So let's say, to keep it simple, let's say that down is plus, up is minus for M1. Now, which way is M2 going to be moving? Up. So we're going to say up is plus, down is minus. So when you do your free body diagram, right next to the free body diagram, you should have your sign conventions. And then that shows the person grading your test, what you're talking about. This way is plus, that way is minus. Notice the sign convention wraps the pulley plus, 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 all the way up and around. Okay? The sign convention needs to agree for each object. Now, did anybody incorporate normal force into this problem? Normal force should not be involved here because a lot of kids put it in because look, if you look at M2, what's M2 doing when the problem begins? It's sitting on the ground, right? But what happens like 1 nanosecond into the problem? M2 comes off the ground, so the normal force goes away. So don't include normal force into your free body diagram. So M2 comes off the ground, so I'm just going to erase the ground here. We don't even care about the ground. All right? So let's start with M1. What are the forces acting on M1? There are two. We have the force of gravity pulling M1 down, like that. So you could label this W. I should say this. Sometimes you'll see it labeled W. Sometimes you'll see it labeled force of gravity. But the way I want you to do it, label it mg. But don't just say mg. You got to say what? M1g, because you got two masses here. So we got M1g down. Now, what force is acting up on M1? Tension. Now just think about this for a second, guys. Just think for a second. Why does M1 accelerate down? The acceleration of M1 is going to accelerate downward. Because why? Because M1g is slightly bigger than tension, right? So if M1g is a little bit bigger than tension, the acceleration is going to be downward. Okay? Now, let's go to M2. What are the forces acting on M2? Well, we have gravity pulling down. We'll label that M2g. And we have tension pulling up. Now just think about M2. Which way is M2 accelerating? M2 is going to accelerate upward. Why does M2 accelerate upward? Because tension is slightly bigger than M2g. Okay? But realize, what do we know about this tension and this tension? They're equal. The tensions are the same. And what else do we know about M1 and M2? The tensions are equal and the accelerations are equal. Okay? All right, so now we sum the forces. So we're going to sum the forces for M1. We're going to sum the forces for M2. There are no x forces in this problem, so we're just going to focus in the y direction. So for M1, summing forces in the y direction. So what are we going to say for M1 right here? For M1, paying attention to the sign conventions that we already talked about, what do we say here? So we're going to say M1g. Now why did I make M1g positive? M1g is positive because what did we say over here? Down is positive. So M1g minus T. Why did I make T negative? Because which way does tension point? Up. So we go M1g minus T. Those are the forces. Hey, man, what did I just do right here? I just summed the forces. What did Newton tell us about the sum of the forces? The sum of the forces will always equal what? MA, right? So we're going to go sum of the forces equals MA, but don't just say MA, you got to say M1A, because which mass did we do this for? For M1. We just wrote an equation. Okay, let's go to M2. So focusing on M2, so up is positive, down is negative. So right, so tension's going to be positive. So we're going to go tension minus M2G, because M2G points negative here. What did I just do right there? I summed the forces. What will the sum of the forces always be equal to? MA, where that's M2A. All right, guys, so do you remember back in 8th grade or 9th grade, do you remember doing this? 2x minus 7y equals 4. 4x minus 3y equals 6. Solve for x and solve for y. What grade did you do that in? Was that 6th grade? 8th grade? I think most kids do that in 8th grade. The thing I want you to realize, guys, the thing I want you to see here, this, so let me erase this. This right here is the same thing as what you did back in like 8th grade. Solve for x, solve for y. What do these two equations have in common? Tension and acceleration. So look, here's the easiest way to do this. I'm going to scoot these closer together. For this situation, what we're going to do is we're going to add the two equations, right? Just put a line here. I'm going to add the two equations. Notice this is t, and that's negative t. So what happens when we add the equations? T and negative t cancel. So you add them up, you get m1g minus m2g equals m1a plus m2a. So now factor out a g, m1 minus m2, factor out an a, or the a, m1 plus m2, like that. And then a is going to equal g m1 minus m2 over m1 plus m2. Now look, I did this because when you guys take the AP exam months from now, in May, the College Board is kind of obsessed with having kids solve in variables. So they could have given you this problem and they could have said, solve for the acceleration in terms of g, m1, and m2. What's the acceleration of this situation in terms of g, m1, and m2? And this right here would be the answer. Okay? But we have numbers, right? So when you take these numbers, plug them in down here, you're going to get a equals 0.239 meter per second squared. That's a numerical answer. And then how do you find tension? Once you know the acceleration, how can you get the tension? Well, you can either plug into this equation, because remember, you now have the acceleration. You either plug into this, or if you prefer, you could plug into this. Either equation will give you the same answer. So when you do that, tension comes out as about 20.08 newtons.